Hello friends, welcome to our new lecture of signals and systems. Today we are going to learn about what is time shifting of continuous time signal and discrete time signal. So suppose if xt is a continuous time signal having independent variable time t, then it can undergo some basic transformation in its independent variable, and these transformations are time shifting, time scaling, and time reversal. In this video, we are going to learn about time shifting of continuous time and discrete time signal. So, suppose xt is a continuous time signal, then it can be shifted in time by replacing its independent variable time t by t minus t naught. Okay, where t naught is the amount by which xt is shifted. Now this t naught can be either greater than 0 or less than 0. That suppose xt is a signal, so then xt can be shifted in time domain by an amount t naught, and t naught can be greater than 0 and less than 0. If t naught is greater than 0, then our signal xt will be shifted to the right side in the time axis. If our t naught is less than 0, then our signal xt will be shifted to the left side of the time axis by t naught units and t naught units. Let's take an example. Suppose xt is our signal. It is varying from in the time domain. Xt is a triangular signal 0, 5 and 10. In case 1, suppose our t naught is greater than 0. Let's take t naught is greater than 0. Suppose t naught is equal to 5. So as stated above, if our t naught is greater than 0, then our signal xt will be shifted in the right side. Our signal xt will be shifted in the right side by t naught units. So 0 will be shifted to the right side by 5 more units. So 0 will be shifted to 5. 0 will be shifted to 5. 5 will be shifted to 5 plus 5, that is 10. And 10 will be shifted to 10 plus 5, that is 15. So this is our new signal. So this is our xt minus 5, where 5 is greater than 0. In case 2, suppose t naught is less than 0. Let us take t naught equal to minus 5. Then our signal xt will be shifted to the left side by 5 units. That means 0 will be shifted to minus 5. 5 will be shifted to 5 minus 5, that is 0. And 10 will be shifted to 10 minus 5, that is 5. So our new signal will be this xt plus 5. Now you might ask that why plus? Because our original representation of a shifted signal is x t minus t naught. We all know that. Now since it is shifted by minus 5, here t naught is minus 5. So minus minus plus, so it will be xt plus 5. So I hope you understood how this altogether came as xt plus 5. Okay, so this is all about the time shifting of continuous time signal. I hope you have understood. So now we are going to discuss about the time shifting of discrete time signal. So similarly, let us consider xn is a discrete time signal where n is a sequence of numbers as discussed in the previous lecture. Then if we shift the time shifting version of xn is mathematically represented by xn minus n naught, where n naught is the amount of units by which xn is shifted in the x-axis. So it will be more clear by an example. Also, the n naught can be greater than 0 or n naught can be less than 0. If n naught is greater than 0, our xn sequence will be shifted to the right side, and if n naught is less than 0, our xn sequence will be shifted to the left side. Now it will be more clear by an example. Let us take xn is a discrete time signal. Suppose xn is a discrete time signal. We are drawing here. This is n, this is xn. So at n equal to, suppose it is n equal to 1, n equal to 2, n equal to 3. At n equal to 1, this is n equal to 1. This is, for your understanding, I am changing the color. N equal to 1, xn is 1, and n equal to 2, xn is 2. At n equal to 3, xn is 1 again. Xn is 1. So this is our xn. Okay, now we are taking first of all case 1 where n naught is greater than 0. Suppose our n naught is equal to 1. So as stated above, our signal xn will be shifted to the right side by 1 units more. Now xn at n equal to 0 will be shifted to n equal to 1. Xn at n equal to 1 will be shifted to n equal to 2. So at n equal to 2, we will get 1. At n equal to 3, we will get the value of x of 2. To n equal to 3, we will get this. At n equal to 4, we will get the value of x of 3. That is again 1. So this is our case 1 when n naught is greater than 0, that is n naught is equal to 1, and this is the time shifted version of xn by 1 units in the right side. Yes. So now suppose we take case 2, we are taking case 2 when n naught is less than 0. Suppose n naught is equal to -1. Then let's draw the axis first, and 0, -1, 1, 2, 3, 4. So, as stated above, if n naught is less than 0, then our signal xn will be shifted to the left side by n naught units. That is, the x of 1 at n equal to 1 will now be shifted to n equal to 0. X of 2 at n equal to 2 will now be shifted one axis in the left side, that is at n equal to 1, and x of 3 at n equal to 3 will be shifted to n equal to 2. So our new signal will be shifted to n equal to 0, and x of 2 will be shifted to n equal to 1, and x of 3 will be shifted to n equal to 2. So this is 1, this is 2, this is 3, and this is our signal xn plus 1. Now you may have doubt that why this is, how this plus sign came, because the general notation of time shifted signal in discrete time is n minus n naught. Now since our n naught is equal to -1, so minus minus it will be plus, so hence it is xn plus 1. Now one question may come to our mind, that what is the application of time shifting signal in examples of sonar signal, in seismic signal processing, in radar. Suppose xt is our signal. Okay, now what happens that, suppose r1, r2 and r3 are our different receivers. Now this signal may transmit through, same signal may transmit through different medium. Suppose air medium, suppose it may undergo, in case of sonar signal, it may undergo the medium as water, and in case of seismic signal processing, it may undergo the medium as rocks. So what happens that you are transmitted the signal at the same time, but different receiver will receive the signal in different time. xt can receive in, suppose xt minus 5, suppose xt will be received in, suppose in different time, suppose xt minus 5, suppose it can be received in xt minus 10, suppose it can be received in xt minus 2.5. So we don't know. Now to model this kind of real world challenges mathematically, we need time shifting of signals.